Hi, welcome to Unit 7, Lesson 1. In this lesson, we'll be learning a little bit more about how to solve problems using the Pythagorean Theorem. So remember in class, we looked at the Pythagorean Theorem, kind of where it came from, how it works, and we discovered exactly what it says right here in this cloud, that when you have a right triangle, and remember again, this only works with right triangles. When you have a right triangle given two legs, triangle, the sum of the square of those legs will equal the square of the hypotenuse. Remember, the hypotenuse is just that, the longest side of the right triangle. So if you take the square of the two leg lengths and add those together, you'll get the square of the hypotenuse. And so that's where we get this Pythagorean theorem that says a squared plus b squared equals c squared. You should recognize in this model up here exactly what we did with the starburst in class. So we saw that this side of the square had a length of 3. And when you square 3, you get 9. So the area of that square was 9 square units. Then you had a length of 4. And when you square that, you get 16. So this square has an area of 16 square units. And if I take 9 squares and put them together with 16 squares, that gives me 25 squares, which is exactly what you see right here. So the sum of the squares of the two legs will equal the square of the hypotenuse. So right here is just an example of like a real world situation where you might see this happen. So let's say I'm going to ride my bike here and then here. So 100 meters and then 60 meters. Maybe that's where the path or the road is. But if there were a path or a road this way, this would be a shortcut right here. That's the hypotenuse. So that's the shortest distance between those two places. And I could use Pythagorean theorem to find the distance of the shortcut, because I could say that a squared plus b squared, equals c squared. So in this case, I know the two legs and I'm looking for the hypotenuse. So I would have 100 squared plus 60 squared equals c squared. So 100 squared, so 100 times 100. So 10,000 plus 60 squared, so 3,600 equals c squared. So then we have 13,600 equals c squared. And then at that point, and to get c, and this is a common mistake, so you can't just stop there. We're not saying that c equals 13,600. If you want to know what c equals, you got to take the square root. So in that case, you could just plug 13,600 into your calculator and find the square root of that, or you can just leave it as the square root of 13,600. Let's look at this example. Two joggers run 8 miles north and then 5 miles west. What is the shortest distance to the nearest tenth of a mile they must travel to return to their starting point? So they run 8 miles north and then 5 miles west. Let me go the other way. They go 8 miles north and then 5 miles west. And it says, what is the shortest distance to the nearest tenth of a mile that they must travel to return to their starting point? So we're looking for this distance right here. And that would, of course, be the hypotenuse. So with the legs, we can call one of them A, one of them B. It doesn't matter. We're going to use Pythagorean theorem. A squared plus b squared equals c squared. So my two legs are 5 and 8. I can put one of them for A, one of them for B. So 5 squared plus 8 squared equals c squared. Of course, 5 squared is 25. Plus 8 squared is 64. And that will equal c squared. So now 25 plus 64 will give us 89. So if 89 equals c squared, so to get c, we'll take the square root of both sides. And so again, you can leave it as the square root of 89. You can plug 89 into your calculator and take the square root. Or I know that the square root of 89 would be somewhere between, if I want to think of square numbers that are near 89, we did this at the beginning of the year where we estimated square roots. 89 is between 81 and 100. The square root of 81 is 9. The square root of 100 is 10. 89 is 8 away from 81. It's 11 away from 100. So its square root should be a little closer to 9 than it is. I wrote 100 right here, not 10. So its square root should be a little closer to 9 than it is to 10. So we might say that C is about 9.4 miles. And so we just use the Pythagorean theorem, square the two legs, add those together, take the square root of that, and then you have the approximate length of the hypotenuse, or the side that we call C. Next example, Oscar's doghouse is shaped like a tent. The slanted sides are both 5 feet long, and the bottom of the house is 6 feet across. What is the height of Oscar's doghouse in feet at its tallest point? Okay, so his doghouse is shaped like a tent. So maybe like that. And it says the slanted sides are both 5 feet. And the bottom of the house is 6 feet across. What is the height of Oscar's doghouse in feet at its tallest point? So the height, so right here, at its tallest point. So we just made a rectangle. We just made a right triangle right here. And we want to know that missing length right here. We have to be careful of here is we cut the base of that triangle in half. So what that whole distance is 6. So what we need is just half of that. So we want 3 right here. Now in this case, we already have our hypotenuse. 5 is our hypotenuse. So we're missing a leg. So I'm going to call this one that we're missing, which would be the height of the doghouse, which is what we're being asked about. I'll call that A. We could call it B. It doesn't matter. You're either leg. You can call one of them A, one of them B. It doesn't matter. So now we'll plug into Pythagorean theorem. So we have A squared plus B squared equals C squared. So I'm going to call that leg I know 3. So 3 squared. The one I don't, we'd already labeled it A. So we'll just leave that at A squared so it matches the picture that I drew. So A squared plus 3 squared equals 5 squared. So that would give us A squared plus 9 equals 25. And then we'll subtract 9 from both sides. So now we have A squared equals, so 25 minus 9 would be 16. And then to find A, we need the square root of both sides. And the square root of 16 is 4. So the doghouse is 4 feet tall. That should look familiar. When we looked at the Pythagorean theorem for the first time in class, we looked at a 3, 4, 5 triangle. And 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. That would give us the square root of 25 is 5. So the length of that hypotenuse is 5. And the height of the doghouse would have to be 4 to give us that 3, 4, 5 triangle. Last one. At Everly's Evergreen Farm, the taller trees are braced by wires. A wire extends from 2 feet below the top of the tree to a stake in the ground. So that's this wire right here. Okay, and you have to pay careful attention to this, that wire is actually connected to the tree 2 feet below the top of the tree. What is the tallest tree that can be braced with a 25-foot wire staked 15 feet from the base of the tree? So here's our right triangle. 25 feet, 15 feet. Now, here's what's a little bit different. We want to know how tall the tree can be. Well, this 2 feet right here is not included in our triangle. So we'll have to come back and add that 2 feet once we find out how long that leg is. Because what we have right here is a leg and a hypotenuse. We're missing the other leg. But when we find that leg, if it wants to know the height of the tree, the tallest tree, I'm going to have to go back in and add this 2 feet. Because that little extra 2 feet is not actually part of our triangle since the wire hits the tree 2 feet below the top. So plug into Pythagorean theorem, A squared plus B squared equals C squared. And so A is 15, so that's 15 squared plus B squared. We don't know that. That's almost the entire height of the tree. And then C squared, so that's that wire. That's the hypotenuse. So 25 squared. So we have 15 squared is 225 plus B squared equals 25 squared. And that's 625. And then we'll just subtract 225 from both sides. And that gives us B squared equals 400. So to get B, we just find the square root of both of those. So the square root of B squared is B, and the square root of 400 is 20. I have to be super careful here because it's very tempting to think that 20 is the answer. 20 is the height from here to here, but the tree actually has another 2 feet up there since the wire didn't go to the top of the tree. So we'll take the 20 we got from Pythagorean theorem, add that 2 extra feet at the top of the tree. And we know that we're talking about a tree that is 22 feet tall. That's the tallest a tree can be to be braced with a 25-foot wire that's staked 15 feet from the base of the tree. And that is it for Pythagorean theorem. So again, just be careful. Make sure you know, are you being asked to find a leg or are you being asked to find the hypotenuse? And that's sort of the trickiest part. And if you're being asked to find one of the legs, so if you're given a hypotenuse and a leg, you have that subtraction step in there so that you can get the variable by itself. And that's it for Pythagorean theorem. If you have any questions or want to see some other examples, let me know. If you're ready for the skill check to be open, I'll be glad to do that. And have a great